ওকে, তাহলে গ্রাফ থেকে আমরা বুঝতে পারি which function is increasing, which function is decreasing. ডিক্রিজিংটা এখনো বলিনি, ডিক্রিজিংটা একই রকম ভাবে হবে। আর আরেকটা টার্ম ইউজ হয়, সেটা হচ্ছে মনোটোনিক্যালি ইনক্রিজিং। মনোটোনিক্যালি ইনক্রিজিং মানে ইট ক্যান বি নন ডিক্রিজিং, ওটাকেও মনোটোনিক্যালি ইনক্রিজিং বলে। তো এখানটায় আমি লিখে দিচ্ছি মনোটোনিক্যালি ইনক্রিজিং। ঠিক আছে, তাহলে দিস আর দ্য টু কনসেপ্টস অ্যাবাউট ইনক্রিজিং, হয় স্ট্রিক্টলি ইনক্রিজিং নাহলে মনোটোনিক্যালি ইনক্রিজিং। বাট নর্মালি এটা ডেফিনিশন দিচ্ছি, আমরা যখন ডেরিভেটিভ ইউজ করব তখন একটুখানি আলাদা হবে এটা, মানে ডেফিনিশন কিছু আলাদা হবে না, বাট দ্য ওয়ে উই সলভ কোয়েশ্চেন্স উইল বি লিটল ডিফারেন্ট। আচ্ছা, এটা গেল এর জন্য। এবারে আমাদের একটা আছে, সেটা হচ্ছে এরকম গ্রাফ, এক্স অ্যাক্সিস ওয়াই অ্যাক্সিস, এটা এরকম এরকম হতে পারে। তো দিস ইজ এ ডিক্রিজিং ফাংশন। তো এটার জন্য আমরা লিখব x1 লেস দ্যান x2। কি করতে হবে এখানে? x1 লেস দ্যান x2 implies fx1 গ্রেটার দ্যান fx2। এখানে কিন্তু ইনইকুয়ালিটিটা চেঞ্জ হয়ে যাচ্ছে। সো আমি যেটা লিখছি এখানে, দিস ইজ নাথিং বাট ডেফিনিশন অফ ইনক্রিজিং ফাংশন অর ডিক্রিজিং ফাংশন। x1 x2 ফাংশনের ডোমেনে থাকতে হবে, তাহলে এটাকে বলা হবে ইনক্রিজিং ডিক্রিজিং ফাংশন। y equal to fx is decreasing ফাংশন, and এটাকে আমরা স্ট্রিক্টলি ডিক্রিজিং ও বলি। Okay, so this is about decreasing function. এবারে আরেকটা ডায়াগ্রাম ড্র করব, সেটা হচ্ছে একটু অন্যরকম, ওই আগেরটার মতো ভেরিয়েশন আছে। So this will be like this, y axis. এটা it can be decreasing, মানে এরকম slowly it will decrease, but sometime it can be constant, again it can decrease. So this is the example of function which is decreasing but not strictly decreasing. So এখানে লিখতে হবে x1 less than x2 implies fx1 greater than fx2, but here it can be equal also, and this is true for all x1 x2 belonging to the domain of the function. If it is true, then we call this function as, and this function is y equal to fx is called, কি বলবো এটাকে, নন ইনক্রিজিং or monotonically decreasing, non increasing or monotonically decreasing. Okay, so this is the definition of these four type of function. Increasing, mostly mainly we will be discussing increasing and decreasing. Other two are little I mean a special case. There some point it may be constant, so there it will be like this. But in terms of derivative, when we will discuss, first diagram এ দেখা যাচ্ছে, in the first diagram, okay, in the first diagram we can see that the function is increasing, obviously graph থেকে বোঝা যাচ্ছে, and that is the definition. If I draw any tangent to that graph, যে গ্রাফটা ড্র করেছি, if I draw any tangent to that, সেই ট্যানজেন্ট এক্স অ্যাক্সিসের সঙ্গে যে অ্যাঙ্গেলটা করবে, দ্যাট অ্যাঙ্গেল উইল বি অ্যাকিউট অ্যাঙ্গেল। দ্যাট অ্যাঙ্গেল উইল বি অ্যাকিউট অ্যাঙ্গেল। আমি একটা ট্যানজেন্ট ড্র করে দেখাচ্ছি। This is a tangent. This is a tangent at this point, and it makes that angle theta here. And we can understand that whatever point I take and I draw a tangent, the angle theta will always be acute angle. If the angle theta is acute, then tan theta will be positive. And we know that tan theta is nothing but slope of a line, that is slope of the tangent in this case. So slope of the tangent is positive as long as the function is increasing. And when I get the term slope of tangent, I have a similar concept in derivative, that is dy dx is also, dy dx also represents slope of tangent. Therefore, what we can conclude here for the first increasing function, first diagram, we can say that if a function is increasing, then its derivative must be greater than 0, because tan theta is greater than 0, because theta is acute. Okay. And similarly, in the second case, if I draw a tangent that will give acute angle, but the points where the function is continuous, constant, there if I draw tangent, it is parallel to x-axis. So therefore, the derivative is 0. So in the second case, dy dx greater than 0 as well as equal to 0. Two possibilities are there. In the first case, only strictly greater than 0. Similarly, in third diagram, can you see the screen?
Yes, sir.
Yes, sir.
Okay. I think screen টা আবার হ্যাং করে আছে। কি হচ্ছে এরকম? আমার এখানে তো মুভ করছে, এখানে মুভ করছে না। Okay, so the third diagram, if I draw any tangent, the tangent will make acute angle. If I draw any tangent, it will make acute obtuse angle with the positive x-axis. Therefore, the tan theta will be negative, and if tan theta is negative, dy dx is also negative. That means for decreasing function, derivative is negative. And for the fourth diagram, derivative is negative as well as it can be equal to 0 whenever the function is constant. Okay, so that is the discussion, but the screen is not responding. Let me once. So if f dash x is greater than 0 for all x belonging to a comma b, then f x is strictly increasing in a comma b. In that interval, it is strictly increasing. Outside the interval, what is happening, we don't know, but in that interval, it is increasing. That is ensured by f dash x greater than 0. Okay. And then similarly, we can write if f dash x is greater than or equal to 0 for all x belonging to a comma b, then fx is non-decreasing or monotonically increasing, non-decreasing in that interval a comma. So this is easily understood by the graph, and similarly I can write if f dash x is less than 0 for all x belonging to a comma b, then fx is strictly decreasing in that particular interval a comma. And similarly, if f dash x is less than equal to 0 for all x belonging to a comma b, then fx is non-increasing. Non-increasing in that interval a comma b. So this is the idea, and based on this idea we can solve all the question based on in this particular concept. Okay, so if I summarize it in this way, I can write like this: f dash x greater than equal to 0 implies and implied by fx is increasing. So those 2 points I have taken together. Increasing means this, and f dash x less equal to 0 implies and implied by fx is decreasing. So if it is told that strictly increasing, then we will not take equal to sign. But normally, if nothing is mentioned, also depending upon the option, we will take derivative whether equal to 0 or not. The meaning of taking equal to 0 is nothing but the function is constant. So that depending upon the question you have to take. But normally, for any question, we have to use this concept that is discussed here. Just this much, if you remember, that is enough. So this is about our discussion of increasing decreasing function. Now let me show you by some another graph here in the next page. Say I have this uh, x-axis here, x-axis, and I have a function y equal to fx whose graph is like this. Something like this. There is a graph of y equal to fx, and let me draw it a little bigger, then it will be easy for you to understand. Something like this. Okay, can you see the screen, all of you?
Yes, sir.
Right. So here I have drawn the graph of a function y equal to fx, and you can understand that, and this is our x-axis. You can understand that the function is increasing up to certain point, and then after that it is decreasing, and then again increasing, again decreasing, like this. So if I just put them in this way, this is one point, say x1, this is another point, say x2, this is another point, x3, x4, x5, x6, x7, x8, x9, and so on. So I have got few points here, and we can say that in the interval x1 comma x2, the function is decreasing, as the graph suggests. Again, from x2 to x3, the function is increasing. Again, from x3 to x4, the function is decreasing, and so on. So if there is a question that find interval where the function is increasing, then if I can draw its diagram, then I can easily say from the diagram that the function is increasing in so and so interval. If I do not know that diagram, then I have to use the concept that is discussed just now here, the concept of derivative. Okay, the concept of derivative is purely algebraic method, and if you can draw the graph, you can easily by looking at the graph you can say whether it is increasing or not. If it is increasing, in which interval it is increasing, and if it is decreasing, in which interval it is decreasing. All those we can see. Here one more important thing we want to check, that is at this point, at the point x1, the function is, I mean, it is like a highest point. It's like a highest point here, and again here it is a lowest point at x2. That means the minimum value. Again in x3, it is having a small maximum value. Again minimum value, maximum value, and all these what I am drawing here is the tangent at that point. Tangent at that point is parallel to x-axis. Okay, so this is our, one more is there, right? So this is our diagram. I have drawn tangents at those points, and we can see the tangents are parallel to x-axis, so the derivative must be 0 for those points. So therefore, if you look at the left hand side, left side of x1, left side of x1, the function is increasing. So from this graph, we can check, we can see that if a function is increasing, gradually increasing, and then suddenly it is decreasing, gradually increasing and going to a peak, and then it is decreasing. So if such thing happens, then there will be a point of maxima. There will be maximum value of the function there. That is called local maximum. Okay, so that will be discussed in maxima minima concept. So here I have just now discussed increasing, decreasing, and this is one of the graph in which you can check how in which interval the function is increasing. But increasing, decreasing, and maxima minima are related. Okay, we can see that if the function is decreasing and then it is increasing, that means there will be a minimum value, local minima. This is called local minima, local max. So we'll be checking that, but before that we will have to solve some question of increasing, decreasing. We will come back to maximum minima again later. So for increasing, decreasing function, what type of questions you can get? Let us solve that one by one. Right, let's take a question. Find the interval. Find the interval in which fx equal to x cube minus 11x square, no, x cube minus 6x square plus 11x minus 6 is, find the interval in which this is increasing. Okay, so this is the question. Try to solve. What you have to do here? Anyone got the answer?
D by
So
dx
minus,
করে
so minus infinity comma 2 minus 1 by root 3 union 2 plus 1 by root 3 comma infinity.
হ্যাঁ ওরম
হ্যাঁ
Okay.
স্যার এটাই
ঠিক আছে, তাহলে আমরা করি একবার এটা। তাহলে fx দেয়া আছে, so I have to find f dash x. f dash x equal to 3x square minus 12x plus 11. Okay, and f dash x, when f dash x is greater than 0, the function is increasing. So if it is greater than 0 implies, so how to solve such inequality? By wavy curve method, but we cannot factorize it this way. We have to find the roots and then factorize. So for that we have to find the root first. What are the roots? 3x square minus 12x plus 11 equal to 0 implies x equal to, yes, tell me, minus b, meaning 12 plus minus root over b square minus 4ac, that is 12 into 11, how much?
132
132.
132 by
6
6. So that will give us some number, say this alpha and beta. We can find what is alpha and beta. So therefore we can say this implies x minus alpha into x minus beta greater than 0, and for that I can use wavy curve method. Alpha the smaller one, beta the bigger one, and be like this. So plus plus minus, so it is positive, means this part you have to take and this part you have to take. Therefore the function is increasing in the interval minus, so increasing in minus infinity to alpha union beta to infinity, where alpha and beta are the root of the equation. That can, so this is simple, as simple as that. Okay, Let us take one more question here. Find the interval in which the function find the interval in which the function are increasing and decreasing. So you have to find that interval, relative increasing and decreasing, both intervals. First function is like this: fx equal to x plus ln 1 minus 4x, and the second one is fx equal to x to the power x. It is given in the question that x is positive. So for these two questions, you have to find the interval in which the function is increasing as well as decreasing. So try to solve. Dash x is 1 plus log is 1 by that, so minus 4 by 1 minus 4x, that is equal to 1 minus 4x minus 4 means minus 4x minus 3 divided by 1 minus 2. So this is nothing but minus of 4x plus 3 divided by, or we can get rid of this minus, 4x plus 3 by 4x minus 1. Like this you can write. These are f dash x. So for increasing it should be positive, for decreasing it should be negative. So for that you have to draw the wavy curve for this. What is the point that I must plot? The point is minus 3 by 4 and 1 by 4. And the wavy curve will be like this. Plus, plus. So from the wavy curve, we can very well understand that fx is increasing in the interval minus 3 comma 4 from negative infinity, minus infinity to minus 3 by 4 union 1 by 4 to infinity. This is for increasing and decreasing in the interval -3/4, comma 1/4. Okay, so this is the thing. We can easily check this. So we just have to differentiate and check its sign, in which interval it's positive, which interval it is negative. Easy. Is it matching with your answer?
Yes, sir.
Right. Second one, anyone has solved? Second one? Second question is fx equal to this. So f dash x you have to find. X to the power x is given.
So second answer 1/e থেকে infinity তে increasing আর 0 থেকে 1/e তে decreasing.
এরকমই কিছু হবে. So for that we have to differentiate. Tell me what is the derivative of fx.
X to the power x 1 plus ln x.
How to find that?
Log নিয়ে.
By taking logarithmic differentiation I have told, and this particular x power x we have solved in the class, and you can remember it, x to the power x into 1 plus ln x is the derivative of that can be done in 2-3 methods I have shown in the class. So here x is positive, so x power x is always positive, so only 1 plus log x is to be checked. So 1 plus log x greater than 0 means what? 1 plus log x greater than 0 means 1 greater than log x. That means x less than 1 greater than minus log x, or we can even write this as log x greater than minus 1. Log x greater than minus 1, which implies x is greater than what? E to the power minus 1. For that 1 plus log x is positive. So therefore we can conclude that fx is increasing in the interval 1 by e to infinity, since the derivative is positive there, and decreasing in the interval. It is increasing from 1 by e to infinity. Whatever is left, for that it is decreasing. So that will be minus infinity to 1 by e. But the problem is minus infinity is not possible because x is always positive, that is given in the question. Therefore the left limit should be 0. So this completes the solution. So sometimes you have to use wavy curve method when the function is algebraic type after the differentiation, and sometimes you don't have to use wavy curve method. You can do it by other ideas. Okay, we'll take one more question here. Show that sin x is less than x less than tan x for all x belonging to 0 comma infinity, 0 comma pi by 2. So this is a subjective type of question. We have to show this. This we already know. We can show it by there's x missing here. Sin x. We can show this by drawing the graph of sin x, x and tan x. or we can show this by using some geometry. But here we are going to show this by using the concept of increasing decreasing function. Okay, so I will show you first part, and that is one of the inequality. Second part you can check yourself. So that is we start like this. Let fx equal to sin x minus x. Okay, sin x minus x. What I have to show? I have to show that fx is less than 0 for all x belonging to 0 comma pi by 2. Now, what is the derivative? This implies f dash x is equal to cos x minus 1. What can we say about cos x minus 1? We know that maximum value of cos x can be 1. So cos x is always less than or equal to 1, means this is less than or equal to 0 for all x belonging to 0 comma pi by 2. So what did I get?
So less than হবে না?
Okay, less than, because 0 is not included, so we just put less. Cos x minus 1 is less than 0 for all x belonging to 0 comma pi by 2. Right. Now if f dash x is negative, we know that the from the definition, not the definition, from the derivative interpretation, that function is decreasing if f dash x is negative. So we can say that this implies fx is decreasing. Fx is decreasing. In which interval? 0 comma pi by 2. So if it is decreasing, also one more thing we can check, that what happened if I take x equal to 0? X equal to 0 means the function value takes 0. Okay, so if it is decreasing here, that will imply 0 less than x, we can say like this, if it decreasing, then 0 less than x, we are going to the definition now. So far we were using derivative, now we are going to the definition of decreasing function. If fx is decreasing, then 0 less than x must imply f0 is greater than fx. Is it correct or not?
Yes, sir.
Because inequality will change. And what is told about x? In the question it is told that x is lying between 0 to pi by 2. So x can be in that. So 0 is obviously less than x. So f0 is greater than fx. And what is the value of f0? f0 is nothing but sine 0 minus 0. That is 0. So this implies 0 greater than fx. fx is sine x minus x. Right. So therefore what we can get? Sin x is less than x. So this is how we have proved it. First part. What is the method here to prove such things? We have to take both the function in one side to prove such inequalities. We have to take both the function in one side and assume that as some function fx or gx, and then check whether the function is increasing or decreasing by using derivative. So we are checking the increasing decreasing nature by using derivative, and once we are sure about it, we are using the definition of that increasing or decreasing function to get the actual inequality. Okay. So similarly you can solve the second part by taking fx equal to x minus tan x, and accordingly you can solve. Is it understood to everyone, or if you have any question you can ask me? Is this clear to everyone? So That was one type of question which can be asked from this chapter. Now let us take another question here. It is objective type question. If what is this? Uh, if fx equal to m plus 2 into x cube, m plus 2 into x cube minus 3 m x square plus 9 m x minus 1 decreases on R real number. That means throughout the real number set it is decreasing. Then m belongs to which interval, that you have to find. Here are some options. Option A, minus infinity comma minus 3 union 0 comma infinity. Option B, minus infinity comma 3. Option C, minus infinity comma 0 union 0 is open union 0 comma 3. And option D, is minus 1 comma 0 okay, union 0 comma 1. So these are the 4 options, and that is the question. So the first step will be like this: f dash x. We have to find out this.
So answer B.
Answer B. We have to check that. So what is our f dash x here? We can find f dash x. F dash x is, can you tell me what is f dash x? 3 times m plus 2 into x square minus 6 mx, then plus 9m. It is given in the question that this function is decreasing throughout the real number. Means this should be negative. It should be negative for all x belonging to R. No such interval, but it is decreasing for all real numbers. So the derivative must be negative for all real numbers. Okay, if that happens, then what can we say? Means if a quadratic, now this side of the on a less than 0, left side of less than 0, we have a quadratic in x. When a quadratic in x is negative for all x, what is the meaning of that? It means the graph of the quadratic will be like this. It will never touch x-axis, it will never intersect x-axis. The graph of the quadratic is like this, always negative. That means the discriminant of this quadratic must be, what should be the discriminant? Discriminant should be negative because it is not touching, not intersecting x-axis. That is one thing. Second thing is the quadratic is downward. That means the coefficient of x square must be negative. Okay, so that is a concept of quadratic equation. Now what we will do here, according to that, we can say 3 times m plus 2 is negative, and discriminant is also negative. What is the discriminant? 36 m square minus 4 into 3 into m plus 2 into 9m. This should also be less than 0. Is this clear to everyone? Is this clear to everyone?
Yes, sir.
Okay. So now let us solve this inequalities. So the first one gives, implies m less than minus 2, and then and we have to solve this. 36 m square minus 3 into 36 m square. That means minus 72 m square will remain, I think. And then again minus, what will remain? What is that simplification here?
Coefficient cancel.
Okay, we can cancel, first of all we can cancel 36. Let's do that. We can cancel 36 from both sides, so we will get m square minus 3 into 3m into m plus 2 is less than 0. So this implies m less than minus 2, that is already solved. And now this part I can take m common. If I take m common, what will remain? M minus 3m minus 6. M minus 3m minus 6 is minus 2m minus 6. That means, let me write it here. That implies m less than minus 2 and m into m plus 3 less than 0, cancelling 2. So we have to use Webby curve method now.
Greater than 0.
Greater than 0, that's right. Should be greater than 0. So for Webby curve, let me take this, and I have to take minus 3 and 0. And the Webby curve will be like this, plus, plus, minus. So therefore, our value of m is therefore m less than -2 and what can I take there? M less than -3 or m greater than 0. So that means now I have to combine this. Yeah? Less than -2, less than -3. What will be the answer?
Less than -3.
So therefore m belongs to -infinity comma -3 union 0 comma infinity. Okay, because this and this is and it is with this whole thing. There's a or between them. So if you combine by drawing lines, you will get this as answer. And if you look at the question, that is option A. Option A is the correct one. Okay, so like this, there can be many questions. Let me take another type of question here. One more type. If phi x equal to fx plus f of 1 minus x. So f is a function and phi is another function which is fx plus f of 1 minus x. And f double dash x is less than 0 for all x belonging to close bracket 0 comma 1. Then option A, phi is increasing in 0 comma half. Phi is increasing in 0 comma half. Option B, phi is decreasing, let me put it this way, in half comma 1. Half comma 1. Option C, phi is decreasing in 0 comma half, and option D, phi is increasing in half comma 1. So these are the four options with the question. Let's see how to solve it.
স্যার আগের কোশ্চেনটা একবার দেখাবেন আনসারটা। স্যার লাস্টে আনসারটা কি করে লিখলেন?
লাস্টে আনসারটা কি করে লিখলাম সেটাও বুঝতে পারছো না?
স্যার এই ইন্টারসেকশন বি ইউনিয়ন সি, তো এই ইন্টারসেকশন বি ইউনিয়ন এই ইন্টারসেকশন সি হয়, তো যে এই ইন্টারসেকশন সি সেটা তো মানে ফাই হচ্ছে, তাহলে 0 কমা ইনফিনিটি কি করে থাকছে?
ও ঠিক কথা বলছো, ঠিকই বলেছো। কোশ্চেনটা কি ছিল? This is decreasing for all r, then m belongs to what? M belongs to what? And আছে a less than 0 and d less than 0, এটাই করছি। ভুল হয়েছে আগের কোশ্চেনটা, আই থিঙ্ক অপশনে ভুল দেওয়া আছে। I have to combine, after combining it will be only minus infinity to 3, minus infinity to comma minus 3. There any option is there like that? Minus infinity comma minus 3. So option A টা কারেক্ট হবে যদি ওই ইউনিয়নটা না থাকে, আদারওয়াইজ কোনো অপশনই কারেক্ট নয়। অপশন বি টাকে আমরা চেঞ্জ করে দিতে পারি টু মেক ইট কারেক্ট। ঠিক আছে, তাহলে বি অপশনটা কারেক্ট হয়ে যাবে। ওকে, ঠিক আছে এবার।
হ্যাঁ স্যার।
এবার ঠিক আছে, ওটা ভুল হয়ে গেছিল। আচ্ছা, নেক্সট কোশ্চেন ইজ হিয়ার, solve this question. So এখানে অপশনে দেওয়া আছে phi is increasing or decreasing, মানে we have to check the increasing decreasing nature of the function phi. The phi ফাংশনের দেখতে হলে we need to differentiate phi, that is the first thing. So if I differentiate phi dash x, what will I get? I will get f dash x plus f dash of 1 minus x into minus 1, means minus of f dash of 1 minus x. This is the derivative. Now if I have to conclude about increasing decreasing nature, then I have to check in which interval this derivative is negative for decreasing and in which interval this is positive for increasing. So now this one is not a function, I mean it's not in terms of x cube like that, so that I can take wavy curve and all. This itself has f function, another function f dash. So to check whether f dash x minus f dash 1 minus x is positive or negative, to check that we must know something about function f or f dash, but we have only one information, that is f double dash x is less than 0. Now what is the meaning of that? F double dash x less than 0, what is the meaning of that? Let me write it
F
here.
dash is decreasing.
Right, f double dash x less than 0 means f dash x is decreasing. Because f dash x is less than 0 means fx is decreasing. So f double dash x less than 0 means f dash x is decreasing in 0 comma 1. So if f dash x is decreasing, then what is the definition of the decreasing function? It will imply f dash, we can write like this, then x1 less than x2 implies f dash x1 greater than f dash x2, isn't it? That's the definition of decreasing function. So knowing that, now we'll come back to this. Here if I take phi dash x is greater than 0, if phi dash x is positive, then the function phi is increasing. So if phi dash x is greater than 0, that will imply f dash x is greater than f dash 1 minus x. Okay, we are going this way now. Now what is f dash? Just now we have seen f dash is a decreasing function. So if f dash is decreasing, then f dash x1 greater than f dash x2, that is the relation, then the other relation will be x1 less than x2. So this will imply x less than 1 minus x. Is it correct or not? Any question here? Is this part understood?
Yes, sir.
Yes. So since the function f dash is decreasing function, so inequality changes when I take out f dash and only take the elements x and 1 minus x. And this implies 2x less than 1. That means x less than half. So we have started with phi dash x greater than 0 and we have got x less than half. That means for x less than half, phi dash x is greater than 0 and so the function is increasing. So therefore our conclusion here is for x less than half, but only up to 0 I can take because the interval is 0 to 1. For x 0 less than x less than half, phi dash x is positive, so phi x is increasing. So in the interval 0 to half, phi x is increasing. In the same way, we can say that for half less than x less than 1, the other part of the interval, what is remaining, we get phi x is decreasing function. Okay, so this is the solution. You check the solution now. So which option is correct? Option A and option B. These are correct. Both the options are. Is it understood how we have applied this information that is provided in the question and also the definition of decreasing function? Is it clear to everyone?
Yes, sir.
Okay. Let us take another question. Okay, this question is, suppose fx is a differentiable function such that fx into f dash x, fx into f dash x is less than 0. This is true for all x belonging to R. For any x, it is true. Then, which of the following is correct? So, option A is fx is increasing. Option B, mod of fx is increasing. Option C, fx is decreasing. Option D, mod of fx is decreasing. Which one is correct? That you have to check. I think again the stream is correct.
স্যার একটু দাঁড়ান please.
Stream time of action. Properties of monotonic function. Okay, এই কোশ্চেনটা বাড়িতে ট্রাই করবে। ওকে, সো এখন কিছু প্রপার্টি আছে সেগুলো আমাদের হেল্প করবে কোশ্চেন সলভ করতে, সেগুলো আমরা ডিসকাস করব। প্রপার্টিজ of monotonic function. ওকে, সো এক নম্বরে আমরা এটা লিখতে পারি, নাম্বার 1, if fx is increasing or decreasing, in bracket decreasing টা লিখছি, if fx is increasing then minus fx is decreasing or increasing, মানে ওখানে ইনক্রিজিং হলে এখানে ডিক্রিজিং হবে, আর ওখানে ডিক্রিজিং হলে এখানে ইনক্রিজিং হবে। নাম্বার 2, if f and g, two functions fx and gx, both are increasing or decreasing. If both are increasing, then f plus g f x plus gx is also increasing or decreasing accordingly. Number two, f minus g or f into g, f minus g, that means fx minus gx actually, fx minus gx or fx into gx or fx divided by gx, means for addition operation it will be same, but for other operations this need not be increasing or decreasing, means প্লাস থাকলে it is must that আগে প্লাস থাকলে হচ্ছে ইনক্রিজিং হলে ইনক্রিজিং হবে, ডিক্রিজিং হলে ডিক্রিজিং হবে, বাট আদার অপারেশনস ইট ইজ নট নেসেসারি, মানে ইনক্রিজিং থাকলে ইনক্রিজিং হবে কি ডিক্রিজিং হবে we cannot say anything. আচ্ছা, এটা গেল নাম্বার 2. নাম্বার 3, if f increases, if one of the function fx is increasing or decreasing and the other function gx is decreasing, means they're opposite. If f is increasing and g is decreasing or increasing, they should be opposite. Then number 1, fx minus gx is increasing or decreasing, but nothing can be said about the other thing. Means fx plus gx or fx into gx or fx by gx. For these three we cannot say anything, can't be said anything, can't be said about them, we cannot say anything. Okay, so this is about addition, subtraction and all. Now we'll be discussing about composition. You know composition of function f circle g. For that what you have to do, we can do it in this way, means in a table you can do it. Let us take f here, fx function fx, then gx, then f circle G, G circle F. Okay, we keep it as F, just F and G. F circle G and G circle. Okay, so here right, if F is increasing, if F is increasing and G is also increasing, then F circle G will be increasing and G circle F will also be increasing. But if F is decreasing and G is also decreasing, both are decreasing, then also their composition will be increasing. Okay, so if both are increasing, their compositions are increasing. If both are decreasing, then also their compositions are increasing. Now, if one is increasing and the other one is decreasing, means F is increasing, we can take, and G is decreasing, then their composition F circle G will be decreasing, G circle F will also be decreasing. Similarly, if F is decreasing and G is increasing, then also both of them will be decreasing. So this whatever I have told here, this can be checked or this can be proved by taking cases. I mean, normal proof is there for this. For all four types, we can give proof. I will give proof of one of them here. It is easy to prove. Which one to prove? Let us prove the last one. Huh? F is decreasing and G is increasing. Let us prove that. So we take like this. X1 less than x2 will imply what about f function here? F is decreasing. So if I apply f here, I will get f of x1 is greater than f of x2. That means if I take x1 less than x2 or fx1 and fx2, their signs are changing. Their fx1 is bigger. So now fx1 is bigger and fx2 is smaller. I apply g on that. G is an increasing function. So if I apply g on that, I will get g of fx1 is greater than g of fx2 because g function is increasing function, so inequality will not change. Okay, so now finally we can write this as g circle f of x1 is greater than g circle f of x2. So we have started with x1 less than x2. With that we have started, and finally we got g of f, g circle f of x1 is greater than g circle f of x2. So inequality is changing. Inequality changing means the function is decreasing. Therefore g circle f is decreasing. Like this, you can prove all of them. Okay, clear? Is this clear to everyone?
Yes, sir.
All right. So this is about increasing decreasing function. You can get direct questions, or you can get questions where this concept will be applied. Um, so that is all today. We in the next class we will be discussing about maxima minima. We'll be discussing
স্যার
about
বলছি স্যার কোশ্চেনটা আরেকবার দেখাবেন যে